Okay, so before you delve into this, you should probably know about binary and hexadecimal notation, and you should have experience in at least one programming language. Um, we're going to try to dip our toes in the water. There's a lot of information that is going to be spilled at once, so we're going to dip our toe of our toe into the water. Assembly is pretty much readable machine code. Every programming language is eventually compiled into machine code, so technically, everything is assembly. How fun! Your processor has these things called registers, and they are physical structures of transistors. I'll pull up a picture of the die, the silicon die of the 8086, so that should show up, and you can see that. But from the assembly programming language perspective, registers are like a set of variables with predefined names, and we can use them all throughout the language. Is your brain exploding yet? Well, it should be, because there's a lot of stuff going on at once. So on the right, I just have a representation of all the 16-bit registers. They all contain 16 bits, or one word of data, ones and zeros. AX, BX, CX, and DX can also be accessed by high and low 8-bit or 1-byte portions. And so a word is 2 bytes. Data can be stored in the general purpose and segment registers. You can only do arithmetic operations on general purpose registers, like adding, subtracting, and comparing, etc. CS and IP, that's your code segment, and your instruction pointer are read-only. Can't be directly modified by the programmer, but the processor does modify them with some instructions. We can still read data from them. And these names are arbitrary for the registers. Their naming convention is related to how some processor instructions handle them. But to the programmer, general purpose registers can signify anything. However, it is best practice to use them conventionally when possible. And we'll go over some of the register names right now. Alright, so the names. I'll just get this out of the way. Yeah, so AX is the accumulator register. It just accumulates data that you're going to be using. You will be using AX quite a bit. It is the register that I use the most, and pretty much everyone else does. CX is the counter register, usually used to store the counter of any loops that you make. The data register is just somewhere to put some data while you're using your other registers. And BX is the base register, which it can actually be used as a pointer to memory addresses in RAM. However, we're not going to do that quite yet. SP and BP are the stack and base pointer. These are related to the stack that you have set up. The base pointer points to the start of the stack, and the stack pointer points to the top element of the stack. If you're not familiar with stack structures, I might make a video on it. If not, I'd count it as a prerequisite, so go ahead and look that up. Now, SI and DI are the source and destination index. They have conjunction with DS and ES. Again, we'll have to cover that in more videos. So onto the segment registers. DS and ES, SS, and CS. Data segment, which is the segment that holds all of your instructions or data that you aren't running. The extra segment, at least that's what I like to call it, is just a segment register that you can use for whatever you have to use it for. And the stack segment is the segment that your stack is currently in, and your SP and BP operate off of the stack segment. And then the code segment is where your code is stored that you're actually running, and the instruction pointer, it points to the instruction that your processor is going to execute. You know, it's kind of hard to teach this. There's so much that you have to grasp at once. I mean, you really have to take any concepts from higher level languages and sort of put them on the side burner, because this is a totally different realm. It's very hard to have visibility of what's happening when you're doing assembly language. Even like being able to dump the data that's in the registers so that you can see it is painful at the beginning. So in these upcoming videos, we're going to get into some actual coding, learn how to use some instructions, and hopefully we'll be on our way with learning assembly. Thank you guys. I'll see you in the next video.